Good morning, Ray sir.
Good morning, sir. எல்லாருக்கும் வணக்கம்.
Your voice is not audible.
Sir, they have to join, students. Mauritius.
Yes, sir.
Sir, good morning, sir. Good morning. Wait,
Check with the sir.
Right, sir.
Naresh, sir?
Sir, good morning. Am I audible now?
It's not audible. You raise your voice.
Oh, still you are not able to hear me out.
Yes, it's not audible.
Okay, give me 1 second.
Good morning, all.
Good morning, Manish.
We are here to witness the inauguration of the Anna University Data Analytics Club. As we all know, data analytics has been a thriving field. It is a part of the Industry 4.0, and so we at Anna University are here to take an initiative, and we are planning to take the club forward with much more exciting activities. I request the gathering to stand up for the Tamil Taiwan. நீராறும் கடலுடுத்த நிறமடந்த கிழிமொழுகும் சீராரும் வதனமென திகழ்பரத கண்டமில் தெக்கனமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிலமை திறம் வியந்து செயல் மறந்து வாழ்த்ததுமே வாழ்த்ததுமே வாழ்த்ததுமே. Thank you. I now request the Department of Management Studies Head of the Department, Dr. R. Magesh, to address with the welcome. Thank you.
Yeah, very good morning all. At the outset, this is a privileged day for making me to introduce our department before we start the program. So as we know that our Department of Management Studies is a very established and prestigious department which is functional under the University of Anna University and College of Engineering. And on the continuous process and efforts of our faculties, who were all involved in another task of NAC, which we are going for the third cycle very soon. With all the outset of hurdles, I thank and welcome Dr. Sheikh Manzoor sir for establishing this program. And many clubs have been on the way and already established. And today is a great occasion to establish another club called as DoMSAU Technolotics. And for this program, I thank and welcome all our senior professors of our department and the administrator from the university for making this grand occasion to be a success for another 2 hours. And also, it's a privilege to invite all my student friends of second year and first year of different disciplines, general management and tourism, for joining and making this program success. And they are going to be a member for this club soon after the inauguration of this club. So this club is going to strengthen our department, no doubt. It is going to be another milestone of our growth of the department. And this is going to involve, this club is going to involve on all the technologics, invitation of speakers, arrangement of workshops, and student seminars, and maybe probably on the online and offline. So we all wait eagerly for the inauguration of this portal and website as well as. So at the effort of Dr. Sheikh Manzoor sir for continuous opening of the clubs and different perspective and different forums. Also thank and welcome our senior professors, Dr. Sendil Kumar sir, and our dean, respected Dr. Suganti ma'am, and all our senior professors, and our fellow colleagues and professors of Dr. Kishore Kumar and Batmavati ma'am, Meena Kumari, Tiruchelvi, Tendral, and Dr. Jayan sir, and Dr. Anza ma'am for joining us with our students' activities. So now, this is a great occasion. Once again, I extend my sincere thank and welcome to the administrator of our university, registrar, and vice chancellor of the university for the continuous support they are extending for all the initiations done by our department under the noble leadership of our professors in different aspects. And at the foremost, today, we all thank wholeheartedly for the invitation expressed by us, by the department, by our student friends, and Dr. Sheikh Manzoor, who is an organizer of this program. Our noble speaker of day today is going to share all his experience on the technological field on the name of information on management. Particularly, the title is focused on information management of things. So the speaker is well-known IT renowned technocrat whose name called as Naresh Kumar Vedachalam. When we Google it, we can see him his contribution toward the technology and profile. So I was also in the morning, I was reading about him, his contribution towards his initiation of the recent tools which is arrived at the technological platforms. So no doubt we are going to enjoy his experience and we are going to learn from him. Sir, we will. On behalf of the department as HOD, on all behalf of my professors, I welcome you, sir. Naresh, sir.
Sir, thank you so much.
Warm welcome and vanakkam, sir.
Vanakkam.
And we
I
now.
hope I'm audible.
Yes, sir. Now you are.
Okay. Thank you so much.
So now with all the non-teaching staff and other support staff of our department, so we welcome you very gradually for next coming series of talks, and you are going to be the pioneer for this club, sir. Thank you and very much, sir. So I thank all the students, friends of first year and second year as being effort on joining this forum. So now I hand over the session to Dr. Sheikh Mansoor.
Yes, sir. I thank Professor HOD and for chairing the session, and would like to have a launch of the event. So with that we'll Murlish, we can launch the club, followed by Naresh sir will be giving lecture on it.
Thank you, sir.
Go to Murli.
I request Harshad to launch the video. Thank you. Followed by this, we'll be having the speaker for the day today is Mr. Naresh Vaidya. Mr. Naresh Vaidya is a senior solutions architect. Welcome, sir.
Naresh Vedachal.
Sorry, Mr. Naresh Vedachalam is a senior solutions architect. Welcome, sir. He has 17 plus years of industry experience. He has 7 years of extensive implementation experience in rolling out IoT platforms. His area of interest and the various sectors he has worked includes the telecom and connected home solutions, multimedia and network industry, energy and utility, smart city and industry automation, fleet management and asset tracking. Thank you, sir. The platform is open for you.
Thank you so much, Malishwar. I first of all, I would like to thank Ms. Sheikh sir for giving me such a great opportunity for being a part of this inauguration, and it's an honor for me being a part of this the club, the Technolotics Club. So I thank each one of the students who are here, and I thank the department head and all the professors who have joined. In spite of the time they have to in the weekend, it's whole a lot of interest. Thank you so much for each and every single person who has joined this call. I hope I'll take this a little interesting with the more of a practical talk, since I just got this invitation very recently. I couldn't prepare much on the presentation as such, but I will try to make it more practical and with my experience of what I have learned in a few years. I'll try to be more interactive and answerable for most of your questions. And I would like to share the technology aspect of this. Okay, so let me start. As I said, I don't have any presentation assets to present, but I'll take it as interesting as possible. Please stop me for questions if you have any. And we have a question and answer session at the end of the session, so you can feel free to ask questions at the end as well. Hope I'm audible to everyone.
You are, sir. You can
Yes, sir. Yes, very much.
Thank you. So, first, let me talk about the introduction. So, the topic itself, it's new. I mean, it's just born yesterday. The topic just born yesterday when I was thinking about what to talk and what would be the subject matter here for the discussion. So, information management of things. We have heard the name Internet of Things as IoT, but information management of things. So the word itself is different for me as well, but I'm just trying to make a collaboration or a combination of information management with the technology aspect. So the collection of data which makes sense for making a decision and which comes out of a closed loop system where we can take the data, do the analytics, and act upon the data for a final and immediate reaction or something like that through the technology perspective. So that's the more agenda or the idea extract of this call of this discussion. So how can we get the information managed in such a way that we can do some analytics and come out with a decision which could change the operation of the functionality of a system or a application in a whole world. So talking about the information first, since we say it is a collection of data, but the data has more importance when it comes to the information management. So collecting the data makes a more important role here. Oh, so what is the collection of data here is? When it comes to the management, we would definitely have multiple applications and softwares for collecting data on a financial ground. For example, in a daily market, as in the share market or any kind of financial market, we have multiple softwares which collects the data and put it on a screen where a user can monitor the data, and that data makes sense when it was put in a dashboard where it can give a graph or it can be used for making a decision. So we have a lot of softwares on a financial background. So what can we do in this? The need for the current scenario is the data which is coming out of a technological aspect. How are we going to handle it for managing the entire system, and how can we improvise the whole, like the methodologies that we follow in an industry or something like that. So in an information management perspective, we are going to see how technology can be, like indulged here so that we get a decision which is made out of this data. So I'm just trying to correlate between Internet of Things with information management. So please stop me if I have any questions. So I'm just going to talk about Internet of Things here first. So what is Internet of Things? Is it a technology? No, it is not a technology. Technology is something that derives out of a particular component or something. But here, Internet of Things is a methodology of handling the data. Okay, so it actually derives. I mean, it actually people say that it has born in the year 1999 as an ideology of Internet of Things, but it was already there. It was just evolved out of some ideation per se. See, for example, we had multiple meters for multiple applications. For example, for measuring the energy, electrical energy at home, we had meters. For measuring the speed of a vehicle on road, we had meters. And likewise, we had meters all over the globe for all the applications. So the data was available at that particular point where we are using the device or where the energy or something is going to be, being consumed. Okay. So the data was available at the end of the application, which means that is called as edge. Edge is the technical term they use where the data is actually generated. For example, in a vehicle, we use the vehicle and we go in a particular speed we will have a dashboard which says what is the RPM, what is the speed, or how much is the fuel level. So we have all these data at the dashboard. That we call it as edge in the technical term. So these were already available. So how it evolved as an Internet of Things is we have the data in the edge, and that data, when connected to an internet where this data gets transmitted to a memory on cloud. It's a common memory out there. So the data gets transferred to the cloud through multiple, architecture. I'll come back to that later, but just wanted to give the ideation of this Internet of Things. So the data gets transferred to the memory, which is commonly available on a cloud, and there is another system which grabs the data from the cloud and put it on a dashboard for us to make a decision out of this data. Like for example, in case of analytics, in a financial background, like say for example, in a financial software, we have number of predictions running in the background with the data what we have in the history. Just the same way, we use this data in the backend to analyze the operation of a system and predict or like kind of decide on the futuristic process. So this is the entire flow of a data on an IoT platform. Like, taking the data from the edge, putting it on the cloud, and then using it on the user end where it can give some meaningful information. So this is the flow of the data on the Internet of Platforms perspective. So as it comes, let's get a little deeper in the IoT concept. So as I said, the data where it gets generated, it is called edge. And the data from the edge gets technically connected to a box which has access for internet, and it could even have a small computational power to decide on what data to be transmitted to the cloud, or should I do the computation here on this box itself instead of sending it to the cloud on an internet. So that box is called gateway. So this gateway is a small computer which can process few of the data or partial data which gets collected from the edge component. This edge could be a sensor, an energy meter, a water meter, or a dashboard from a vehicle. As I said, this data can be generated out of any particular metering technology. So it could be a sensor also. So the data comes to the gateway. Now, as I said, this gateway is a small computer where it performs some action on the data, and it can even do some decision on its own. That is called as edge computing. I mean, I'm just giving a very basic concept. It has a even more deeper, perspective of each and every data being handled here in the edge computing as well. But just for the ideation, this is called edge computing. And I may have multiple edge components. Like for example, let's take in a mall, example of a mall where we have multiple stores, and each of the stores will have energy meters connected. All these energy meters will talk to one common gateway, and such common gateways may be existing all across the mall. Like for example, it could be around 100 gateways in a particular mall for collecting all the data from all the stores. So that kind of an environment or architecture, we call that as a mesh architecture, where so many edge components will be talking to multiple edge, multiple gateway, and the multiple gateway talk to one common gateway and then connect to the internet. So I hope I'm made clear. If there is any doubt, please stop me there. So this gateway, when it comes to the gateway process, a mini computer, when it connects to the internet, as soon as the data being processed or if it has the computational power, if not, all the data is is transferred or sent to a cloud storage, where we call it as, and we have multiple clouds, AWS, which is the Amazon Web Services, GCP, which is the Google Cloud platform, and we have Microsoft Azure. So many of such cloud computational architectures are available on the market, and it is all we have pre-used cloud as well for our own purpose. So all these data transmitted to the cloud, and this cloud is much more powerful, and it can handle a lot of data, like big data. For example, if just like a Facebook, where we enter some comments or upload the images on YouTube or something, it goes to a particular cloud space. So there, it has more computational power than a gateway on ground as an edge computing, and it will compute or it will do the analytics. So we have very different applications for such an analytical operations. For example, with a small computer, with a or a small camera, so CCTV camera which is installed in any of the locations, it could be on road. Now we have a lot of CCTVs installed in the road and so many other common public areas. Okay, are these going to be manually monitored? No. All the images gets to a cloud space where we have the artificial intelligence, AI and ML, machine learning process. All these data being analyzed on a cloud, and we will get the incidents created. For example, someone is not feeling well, they just got down, or if there is any event on road, we get notified. If there is any malfunctioning on any of the system, we get notified. All these analytics are being done with the image processing. This image processing can also be done in the cloud where we get some decisions made, and that information is sent to a screen where we can monitor, and so it will show you all the data which is available out of the information which we got from the edge devices. So analytics is a part where it can do a lot of operations for making some decisions out of the data which we got from the edge. Okay, now let's get into the field of industries where we have implemented this information management. How are we going to use the word information management in an industry? I'm just going to take a real-time example where I have worked, and we implemented few of the solutions across the industry for multiple purposes. Okay, I'm just going to take an example of a oil packaging industry. In that industry, we have safety issues where people will not obey wearing a hard hat, which is an yellow color or multicolor hard hat, which we have to wear in an industry. And we will have to, employees have to wear a glove. Now, there won't be any manual process who has to monitor all these and report to an admin where he can take some corrective actions. Now, this has to be dealt in a technological aspect. So we have a camera where it can take the information from the image and do the analytics and say if the person is not wearing a hard hat or a shoe or a glove or something which is to be in a specific area, in a specific real estate. So the same way, we take this information and we use this information, we use this data as a history where we can monitor the performance of an employee or the performance of the whole plant, and we can make some decision with these data, right? So we are actually doing some managerial activity with the data of with the data what we have obtained from a technology aspect, and we are using the same data for improvising the efficiency and operations of an industry. And just like that, I can give you many more examples where we have analytical engines, where in case of a smart home, where so many sensors can be installed and we can read all the data from the sensors and make some decisions out of it and do some automation out of these data with the computational power, for such say. So we have information to be managed, the information available from a technology aspect as well as on a financial aspect. We can have these computational power and use some hardware also. Like there will be a hardware mini computer to do all these analytics, right? So I'm just trying to kind of do the exchange of technology and the ideations between Internet of Things and information management. Okay. Let me go to the census part of it. I'm sure if anybody would have seen For example, if you're crossing, if you're going in front of a door in a mall, it automatically opens, right? So there is a sensor for making some decisions that somebody is in front of the door and it just opens. So such sensors we have all across, the industry. For example, in an agricultural industry, we have sensors on the farm, on the field, where it can read the humidity and temperature of the soil and the water. Like if it is going to be the humidity is very low and it has to be watered right away. It has its own sensor and activation hardware which can play a role and do automation of the entire farm, okay, the field. So such sensors you might have come across in your day-to-day life. I'm just trying to, show some of the sensors right now, and I will give you a small demo, a practical demo of, reading a data from a sensor at home. I'm just going to show you in my home. The data is being used for automation of some of the appliances at home. Okay. Is there any questions till now?
So since you mentioned Azure for cloud platform, and I just want to know which one will you prefer, Azure or AWS?
Perfect. So, see, cloud is AWS and Azure, or even they are actually equally competitive. The way we choose the cloud is we should check, for example, in case of a geographical perspective, if you go to Arabic countries like any Middle East countries, they would not allow any of the data to go out of their geographical location. Even if it is a cloud, the entire infrastructure of the cloud has to be installed or it should be implemented within the geo. I'm just taking an example. So likewise, there is no good or bad between these clouds. It actually happens according to the application of what we are trying to do. AWS and Azure are equally competitive. Only thing is, for example, if you have a Microsoft-based tools, like I'm just taking an example of Office. See, if you are using Office, what will be the email account that you'll use? Will you use Lotus or will you use Outlook?
Outlook.
We'll go with Outlook, right? Because Microsoft is already there with me. It will be easier for me to have an interaction and sharing the data between IBM and Microsoft. When it comes to that, I already have Microsoft in my PC. So let me go for Outlook. So I hope I'm making sense. The way we select the cloud is actually not with the computational power or computational power of the cloud. It actually has a major role to play within the system that we use. Because for the customers in our field also, the customers will decide, our clients will decide, okay, whether I should be going to AWS or Microsoft Azure or even on-prem. It could not be even both of AWS or Azure as well. I would like to have my own cloud at my own pace. So to answer your question, it is not that one is better than the other. It actually happens on your application, on what is your way of approach.
Just one more follow-up question.
Sure.
So you mentioned that the Arab countries insist upon data localization. That is, they want their clouds to be stored within the geographical boundaries of the country.
Correct.
And so when there is more data localization, we prefer Azure. What is it in Azure that we have that is giving it an advantage for data localization?
It is just the implementation of infrastructure. For example, AWS. Just answer your question. AWS till 2019, they did not have a geographical infrastructure um, around Middle East for any cloud operation. It was all across the globe, like Singapore, Indonesia, Philippines, UK, and some places in South America also, but not in Europe. Sorry, not in Middle East. So because of this policy being rolled out with the Arabic countries, they started implementing some of their infrastructure on like Arabic country for just for their operations. So before that, Microsoft was already there. You know, it is not localization in the sense that it is not that the data will not go out. Definitely, if I am approaching for a server which is available in Arabic, if I try to connect with the server, it will get connected because it is on cloud. But the only issue is they want their infrastructure to be present on a visible location where they can just go and travel back and they can see the security aspect of it.
Yeah, that answers my question. Thank you, sir.
Thank you, Mr. So can I move on? Is there any other questions from anyone, please? Hope I'm not boring. Okay,
No,
I'm just
sir.
trying to take it a little more practical as well. See, some of the edge components that I was talking about, a computational power with a small miniature hardware. You know, I don't know if many of you would have seen this. This is called a Raspberry board. Hope you might have seen it.
Yeah, Raspberry Pi, right?
Raspberry Pi. So this plays a very major role in case of a IoT gateway. So this has more of interfaces which would recommend or which would demand for connecting many of the sensors, which is called as edge in case of technological terminology. So we can connect many of those sensors to this small board, and even we can have the image analytics like AI and ML models, AI and ML engines running on this board, and this is very similar to a small computer. I actually use this as a computer. I connect it on my TV, and this can run on Linux. Even there are like specific Linux which we can port onto this board to use it for our own different applications, personal applications. So this is one of the boards for Edge.
Excuse me.
Yes, sir.
This device, is it giving any robust defense against the spoofing activity or attacks?
Yes, that's what even I mentioned. When I say it is a Linux operated machine, it can even have its own flavor. There are different flavors of Linux which can run on this board. And most of the applications are secured already, but there are always chances for spoofing in the sense of malware or something which can get into your computer, right? So the same way, it has its own firewall as well, a software firewall, and we can do whatever applications that we need. For example, as you said, if I'm using this for a security purpose on my for my home, I can have a more secured Linux, which is only accessible for me with all the security applications installed on this. Yes, it is possible.
Okay, thank you, sir. How about the cost effectiveness to the society at large of this?
Okay. Okay, I'll come to that point.
Okay, sir. Thank you.
So the Raspberry Pi board, as I said, it's a very similar to a computer. It can do everything as a small computer. Not just running a server, but it can run a server, but very at a domestic real estate. For example, I can do the server running on a Raspberry Pi for my home or for my entire community, apartment community. Okay. So this is another board, which is Arduino Uno board. Which this is also called a edge device where it can connect different sensors and take the data to the cloud. I mean, not to the cloud, but to the gateway. This doesn't have any internet facility for now, but the same Arduino has come up with the Wi-Fi option as well, where it can act as a gateway also. For example, let me show you this. This is the sensor. This is called a PIR, passive infrared ray sensor. This is actually installed in the entrance of a mall where it identifies a person is standing in front of this and the door has to open. That decision is made by this sensor. This is the passive infrared ray sensor. So this sensor connects to this device where it actually sends it and sends the data to this. And this board, as an Arduino, which could be capable enough to connect to the Wi-Fi or any internet, even for a GSM board, we can interface it, and that data gets shared with the cloud. For example, just like what we do, some products have already come in Amazon as well. Like you can switch on your light or switch on your, you can control your device at home from anywhere in the world through a phone, right? So such devices, such applications are all possible because of these kinds of sensors and gateways. Okay, let me show you one more component. This is a small project which we did for a competition at home. I mean, for in our community. So, what does this? The purpose of this computer or a chip is, for example, let me take this out. I'll be more interested to share, even more deeper details of this. But I'll just talk with this very minimal detail right now for the.
So is that ESP8266?
Exactly. So this is ESP8266, and this is called as Node MCU, right? So this chip, the small part of this entire board, is capable of connecting to Wi-Fi and take all the data from the edge, from the sensors to the cloud directly. And we can do many analytics even on this board as well. It has its own memory as well. But we take this data to the cloud to do some operations on the cloud and do some data analytics as well. So I'm just trying to show you components like in an architecture of an IoT, how its data on edge looks like, what is that edge component, and how does the gateway look like. This is all very, hobbyistic components. But when it comes to industry, most of the major players on the industry, like Intel, IBM, Broadcom, they are all in the manufacturing platform of gateways and sensors. So just for the understanding purpose, I'm just showing you all these data, all these sensors. Okay, let me show you a small demo. Just give me 1 minute. Let me share my screen. So in the meantime, please, if anybody has questions or anything that you want to know, please let me know. If I know, I'll answer, or I'll take some time to answer.
Sir, regarding the cost effectiveness part, could you enlighten us?
Yes, sure. So when it comes to Raspberry Pi, it is almost about let's say 4,000 to 6,000 rupees for one board with Wi-Fi capability on it. And if you want a cheaper version of the Raspberry is also available, but it may not come with Wi-Fi. But at the same time, you can use the board which I showed you, like A266, which is available for 200 rupees, which can also act as a gateway and like share the data on the cloud. So cost effectiveness for a small like non-industrial purpose, it is all in this range. But when it comes to industry with a certified certifications on the security aspects, it might cost 25 to 30,000 per gateway.
Thank you, sir.
Sir, I have another question.
Please.
Since this IoT platform involves on-cloud analytics, obviously you will also be dealing with big data coming in. Similar to my previous question, there are again various choices available for big data tools also.
Yes.
It could be Kafka or Apache or Spark, things like that. So there are trends which suggest that Kafka is the leading tool being used nowadays. Can you just give a comment on that? Why is Kafka becoming popular?
Exactly. See, Kafka is becoming popular just the way, for an understanding purpose. Let me put it in a very simple format. Kafka is readily usable. Like you don't need to have deep knowledge on software, or you don't need to be a very high techy person to understand Kafka. Kafka is something that, okay, if you want to implement a stream of videos from one container in the sense, like for containerizing the entire component of application. For example, now we are downloading an exe file, installing it in a computer, right? We don't need what is there in the exe file. Exe is a complete bundle of whatever is needed to run a particular application, right? Similar to that, in the technology point of view, for an industry or an entire for an application. For example, if a ship is to be monitored, we do programming and we do all testing and we prepare a software which can monitor the location of a ship. Okay. Now the same application has to run in thousand number of ships. Okay. I don't know what is there in the other ship, what is there in the fifth ship, 100th ship, but I need this application to run in all the ships without, like, we call that as vessels, right? So these ships are called as vessels. So we want this to be running in all the vessels without any problem. Now, I cannot go to each and every ship management and say, sir, you need to do this first, do this second time, and I mean, the third step is this. I cannot say that. So Kafka is something which helps me to containerize the whole concept and just give it as like an Excel exe file. I'll bundle everything and I'll put it in a container and stream that to the other vessel where they can just click of a button, everything gets done. So Kafka is a very simple and doable application or a software. So that's why people go, just like Python, We have embedded C, we have JavaScript, we have Node.js, but people go most easily to Python just because it is easy to understand and implement. So that is the only reason.
Sir, how about the integration issues with Kafka and the cloud?
Okay, when it comes to integration part, there are multiple, we say that is called as adapters. We call Spark. The Spark is one of the adapters for Kafka. So there are multiple connectors or multiple modules which get interfaced with Kafka. Kafka is not a single standalone unit. It has to go with some other components as well. So it has multiple interfacing modules available for that, and we can use, again. It depends on the application what we use. So for a video streaming purpose, we can go with Spark, or for a data which is very light, we can go for Connect. So there are a lot of other applications available, a lot of other data adapters available for interfacing with Kafka.
Yeah, thank you, sir. The answers.
Welcome. Okay, let me share my screen. I hope my screen is visible. Is my screen visible?
Yes, it is visible, sir.
Okay. Yeah.
Yes, sir.
Okay. Let me show you this. This is just in front of me, which is installed in my home. This is for reading the energy consumption and doing some analytics for reducing the consumption of energy on an air conditioning system. So what I have done is, the blue small piece of the hardware is a current sensor. So this current sensor is connected and it reads the current, it reads the consumption of current and sends it to this piece of hardware, which is the ESP8266. Now, the data comes from the small blue color board, which is the current sensor. It sends the data to the ESP8266, which is the gateway. So this blue box is the edge component, and this black one is the gateway component here. So the data comes out of the blue small component edge and then goes to the ESP8266 gateway. Now this gateway sends the data to a cloud, I'll show you that. See, this is the cloud I'm using right now. This is a ThinkSpeak, which is called as ThinkSpeak Cloud, where it has its own. We don't have to do anything. It is all customizable and free to use. So if I switch on the AC, you can see this current sensor from zero point 0.1 milli, sorry, from zero point 0.1 amps or zero point 0.2 amps. It will shoot to around, let's say, 8 or 10 amps. This was running for almost a week now. Let me switch it on. See, from from 0.08, no, it should go higher as well. It is not just red yet. And these reads the data for every single minute. Every minute, the current consumption is read and it is sent to the cloud. Now it is like what, 11:26. It has sent already. We will get the next data in a minute. So this is the cloud which I was talking about, and which has the dashboard as well. So we get the data from the edge through the gateway to this cloud. Now we can do some computational operations here. Okay, not ready yet. Okay, now we got it. So it's like 4.79 amps of current like consumption right now. So as I increase or decrease the temperature and let the compressor run, it will consume more power. We can see that right away. And likewise, I have at my home where I have already installed all the appliances like light and fans and everything to be controlled on my phone. All my switches like TV, speakers, and everything will be installed or controllable on a phone application where we have, I'll show you this. This is the small hardware. I hope I'm able to make sense here. So this is a small hardware which connects to my Wi-Fi, and I can access this component through the mobile application and switch on and switch off devices. So like just like Amazon, we hear a lot of ads, advertisements on Amazon Alexa, right, and Google Assistant. So all this can be done like by ourselves. I mean, we just have to get all the components and put together with a software. That's it. So I hope I'm able to make sense here. So now the current is being sent, and it has sent the data to the cloud, and we are able to see that in the dashboard. With this, I can even do some like computation for like calculating the current and then scheduling the operations of any appliances for that matter. For example, switch on an AC from the remote and set the temperature of AC when I'm away from home, and when I reach home, it should be properly set. So something like that. We can control anything at home with this IoT-based devices. Okay, so I hope I made a few sense at least with this presentation. I'll wait for some questions if there is any to answer. I take it as no questions. I thank the entire team and all the people out here for patiently, listening my conversations. And thank you so much for this opportunity. I look forward for more practical demos and more papers to be presented. Thank you so much, Shikhar and head of the department. Thank you.
Thank you, sir. That was indeed a very nice and interesting session. I request Professor Dr. Sheikh Manzoor sir to deliver the vote of thanks.
So good afternoon all. So it's very actually I thank the head of the department for accepting the kind of ideas and making it to implementation. And also I thank Professor L. Sugandhi, Dean and Dean and Professor Basid,